Everybody, this is welcome to the July NYJavaSIG. Tonight we have Billy Korando from Oracle. They speak on Java and data-oriented programming. Is it really better than OOP? We're going to find out. But before I turn everything over to Billy, just one quick announcement. As you might know from possibly this wall, if you're from seeing this on video or people in the room, we normally don't meet here. We met here one year.
In my experience, you do.
You were here last year, a year ago, Billy was here. Over the past few weeks, we've had a great conversation with Terrace Guy. We've been meeting at Terrace Guy. So Terrace Guy has agreed to host us every month now going forward for the rest of the year.
Nice.
So except for October. But that's a little bit further out. So in October, we're going to meet at Touro University in Times Square. So it's going to be one of a special meetings. But all the other meetings are going to be at Terrace Guy. So now you don't have to remember where it's going to be at Terrace Guy near Bryant Park. And we'll have a formal announcement because, you know, Terrace Guy, this is really good for both communities. It's good for us, of course, and it's good for them to get exposure to, to the Java community. We get exposure to what they're doing. They help us with meeting space. Hazelcast has provided the pizza, so thank you, Hazelcast, for the pizza. And that's it for me. The date of the next meeting is August 4th. And who's going to be here? It's going to be Ted Young, who's going to talk about test-driven development. He has, believe it or not, a board game.
Yeah, yeah. That's
right. It's a board game that teaches people test-driven development. So he's going to come here and show, and we're going to play the game. That's going to be really, really cool. Not here, but we're going to be at Terrace Guy. And our second speaker is Simon Ritter, CTO of Azul. And we're going to have a game on modern Java puzzlers. So we're going to play a game. So it's going to be basically gaming, two speakers on gaming. Nice. So that's going to be a lot of fun, August 4th. That's going to be a Tuesday. So it's a little unusual for us, but that's going to be a Tuesday. Okay, here is Billy Korando.
All right, thank you. Thank you, Frank. Thank you for hosting me and going through the effort of finding a meeting space, because I know from people experience myself how difficult that can be. So I do appreciate that. All right, so we're going to be talking about Java AS Data. As mentioned, my name is Billy Korando, Java developer advocate with a small company called Oracle. But you know, don't hold it against me too much. I'm an okay person otherwise, and okay. So important information, please at any point feel free to ask questions. We're here to learn about data-oriented programming, so more than happy to answer any questions as they come up.
And if you ask a question, somebody's going to bring a microphone.
My beautiful assistant, Frank, will pass you the microphone. Also, feel free to reach out. You can shoot me an email at billy.korando@oracle.com, or you can reach out to me on LinkedIn at that URL. And lastly, you can get a link to this presentation on my GitHub pages page. So with that, and I guess one other bit is if you do leave with an intense desire to know more about Java, we have some great sites that we maintain for my team helps maintain. So we have dev.java that provides a lot of tutorials for learning about Java features. Actually, somewhat relevant for this, we also have like the Java Playground, which is an in-browser dialog box where you can write arbitrary Java code and execute it. So in this case, it would be useful because it's all about like Java language features. We also have Inside Java. That's good for keeping up on the latest of Java, our YouTube channel, and our Inside Java podcast. All right, we'll go through the agenda for tonight. First we'll cover what is data-oriented programming. It's definitely not as super well known, or at least everyone's probably going to be familiar with object-oriented programming, so obviously want to at least level set. Then we'll go into why are we talking about this now within the Java world, and then we'll go through the design, when to use it, practical uses of data-oriented programming, and then also what the future it holds for Java and data-oriented programming. So What is data-oriented programming? Before I get into that, let's just go ahead and just like level set a bit on what is object-oriented programming, just so we can better contrast data-oriented programming against it. And of course, big thing with object-oriented programming, it's a modeling both the entities and processes, so it can have both state and behavior, and also extending off of models as well. So the kind of example I went through is like building a application for running conferences. And so here in this one, like I would have a model of like an attendee, which could have like a first name, last name, company, email, as well as the ability to favorite presentations. And like one of the things within that, I could be updating and removing, modifying that list as needed for adding and removing favorited presentations, because that makes sense. That could be something that will change over time. Also, for like setting the email, I could have logic directly in there as well on what's a valid email. Because I don't want to have to rewrite a bunch of stuff, I could also have like a workshop attendee, which extends off of the normal attendee, where they could also have a list of workshops. And then I would have logic for adding a workshop. And again, here I would have maybe some logic on, I guess that should be a method, not a parameter or a variable, but like having a method, like, is this a valid workshop to add, where I would maybe have some sort of business logic, validating, like, is this workshop, do you have like a conflict in your schedule with that workshop? Is that workshop full or available? So like there could just, again, be some sort of business logic to say, is it valid for this attendee to sign up for it? So again, mixing of state and behavior, the ability to modify and mutate state as well. Yeah, so mutable state abstraction, and then also inheritance. Okay, so data programming or data-oriented programming, in contrast, is defining a system by its data, or specifically its immutable data. I mean, of course, that's kind of to be given when we're saying data-oriented programming. And then this data is acted upon by operations that's manipulating that data from the outside. So the defined characteristics, again, as I mentioned, the data would be immutable, and it would also be fully transparent. There wouldn't be any hidden states within your data modeling. Again, it would be important to model the data, the whole data, and nothing but the data. Another key thing, and I think probably one of the things I really like about it, is making illegal states unrepresentable. There's been so many times in my career where I've been stung because like a field that shouldn't be null was null, and if I was to find an object to where that just isn't possible, or just that field can't be blank, or whatever could be an illegal state, that would have been very helpful for reducing a lot of errors. And then also separating operations from data. These aren't necessarily hard and fast rules. This is kind of, so one of my colleagues, Nikolai Parlog, he put together an 8-part series kind of going through the concept of data-oriented programming in Java about 2 years ago, and I would recommend that, and I'm just kind of borrowing these kind of principles as well from him largely. That said, data-oriented programming, as is so often the case, it's not new, and it kind of even goes all the way back to the 1970s, specifically what's called the expression problem, which is a distinction when you want a distinction between the abstraction of the data and objects. That's a link to the Wikipedia article on it, but it was by, I think, Philip Walder, which is, I believe, like a Scottish professor, I think mathematics or computer science professor. But in short, the expression problem is you either have two options. You have polymorphism, where you can add new subtypes, but you can't add operations to them because there could be hidden states, or you can't necessarily always be able to add on all that state. Or you could have pattern matching, where you can add operations, but you can't add new subtypes. And we'll get a little bit more into why that is. All right, so data-oriented programming, as I kind of mentioned, it goes back all the way to the 70s, and obviously Java, we're just celebrating our 30th anniversary just last May, or May before last. But why are we talking about it now? Why haven't we talked about this back in the late 90s or early 2000s? And that's, of course, because it wasn't until very recently could you actually model data-oriented programming in Java. And so there's been a number of semi-recent features now that have enabled this. The key one and the first one was records. These were added all the way back in Java 16. Man, when was that? That was like 2022 or something like that. I mean, that's a long time ago, right? But it allows for the transparent modeling of data as data. So when you define a record, you define all of its components, and that's the only fields then that can be a part of that record. And of course, with a record as well, it automatically generates accessors for these components. And so that ensures the data transparency. You also can't define an instance field within it outside of when you're defining the record. So that way there can't be any sort of hidden state in there. I can't have like a Boolean like, oh, does this person have a company or not? That's like internally for, formatting out like the printing of it or something. That's just not possible with a record. I also can't extend off of this record either because records can't be extended. Oh, yeah, that's right. I forgot. I specifically mentioned all that. Oh, another thing is also records. They have to go through the canonical constructor, so the constructor that sets all their fields. And of course, that's also key towards avoiding unrepresentable states to make sure all the fields are being initialized. Of course, there would be some more to that about doing validation within your constructor as well, which I believe I get to a little bit later. The second key enabling feature was the addition of sealed hierarchies, or as Jeff would call it, sealed classes. That was in Java 17. And so this allows classes to define who can extend off of it. In this case, I'm using an interface rather than just a class. But yeah, I have a sealed interface, and then I'm using the permits clause, and I'm saying, okay, only standard attendee, workshop attendee, and speaker, these are the only classes that are allowed to implement, in this case, the conference attendee interface. And then I define those as records, of course, which are also all implicitly final, and as we just mentioned, cannot be extended either. So this enables what is called algebraic types. Records are product types where they're a compounding of types, the various fields or the various components within that record. And then there's the sealed hierarchies, which are sum types, which are an OR operator where something must be within one of the subtypes of it. Like so, put them all together, like that covers all the possible paths within the sealed hierarchy. And then algebraic types work really great then with pattern matching. And so there have been several examples of pattern matching that have been added to Java. The first one was also in Java 16 with pattern matching for instance of, which isn't quite as interesting. We'll touch on it a little bit, but the more interesting one is pattern matching for switch, and then also record pattern matching for records as well. There's also the unnamed patterns and variables, which I'll get to a little bit later, which is nice for convenience, for some convenience sake. So what's really great with pattern matching and with switch and records is, again, you can use it for algebraic types to create like sealed hierarchies. So in this case, like let's just say I have some sort of function within my application to send out attendee emails, and then depending upon the type of an attendee, I would send that would modify the look and feel of that email. So for like a standard attendee, I'll just send like standard welcome. If I have a workshop attendee, if that workshop, they haven't signed up for their workshops, then I would maybe update their email being like, hey, Billy, you haven't signed up for any workshops yet, and give a link to that based upon that. Whereas maybe for a workshop attendee that, is signed up for it, then maybe I would just include like, hey, here's the 2 workshop classes you signed up, here's the prerequisites to that you'll promptly ignore. Right, Gene? No one ever pays attention to the prerequisites. So there would be that. And then like for a speaker, again, it's something like another speaker email. But because we are using conference attendee, and as I defined it as a sealed hierarchy before, and as being the sum type, that means, I defined it saying only standard attendee, workshop attendee, and a speaker. Only those can extend off of it. So I don't need a default case because the compiler knows these are all the potential options. These are all the potential paths that this code could go down within this switch. This can be very helpful because this helps reduce the possibility of introducing errors. It could be very easy within your code to at some point we add some new attendee type, some VIP attendee type or something like that. I don't know. But when we do that, it could be very easy before when we didn't have like a sealed hierarchy and we would have like a default case to accidentally introduce a bug where we weren't properly handling like a VIP attendee. Now, if we were to add that, we would get a compiler error because now this switch is no longer covering all the potential code paths because it's no longer a fully complete sum. Farther pattern matching with switch and records is you can basically record patterns are kind of almost like a deconstructor to a record where I can easily access all of the fields within that record to then do whatever I need to do with that record or with that information. Also in here, I am using the unnamed patterns as well, in which case the only fields I care about from the speaker is like first name, last name, company, and profile picture because I'm creating like a speaker page, and some of these other fields for like their presentations they're signed up on. Maybe I just don't care about that in this context. So rather than having to either define a bunch of variables I'm not planning on using, I can just replace that with an underscore just to make that a bit easier. It's also cleaner to read because now I'm not defining R for like myself when reviewing this code or some other developer. I'm not distracted by a bunch of unused variables. So, all right, so those are the features that allow us to write data-oriented programming applications. So what does it look like to kind of design one as well? So again, it's key to model data transparently. For operations to be able to exist outside of the models, you can't have any sort of hidden states that will allow them to fully operate on those model classes. So again, records, as I already covered, it provides this naturally. You can't define any sort of private fields that are only internal to the class, just because if you attempted to do that, if I attempted here in the body of the record to, again, define string hidden field in there, the I would get a compiler warning because that's just simply not allowed. So again, records provide that naturally. But of course, you can also do this with a standard class as well. Again, here's standard class, standard attendee, where I'm still implementing the conference attendee interface. And then it would just be about like making sure you have a canonical constructor to make sure illegal states can't be represented, making sure that all the fields are final, that there isn't any hidden field in there as well, that they all have access. So I mean, be following like basically all the patterns that a record is already doing more or less. I mean, of course, if there's a reason you need to still be using a class for whatever reason, you would just kind of want to still continue to follow those principles. Yeah, so modeling the data, the whole data, nothing but the data. So expressing uncertainties and ensure equity between the data. So let's see. So that is, again, where sealed hierarchies can be useful, where when defining a sealed hierarchy, you're defining all the potential types within that. That was a difficulty sometimes before, where you could define a class, but then you had no control over who would be able to either implement that interface or extend off at the class other than making it final. So you can never always know all the potential alternatives, at least just from reading the code, and there wasn't any way to also define in code the limitations on the potential alternatives. So also, again, with modeling all the data, is also making sure for how equity is expressed. So by default, the JVM will provide you with equals and hash code using all of the fields within a record. But perhaps that might not always make sense for how equity is performed. So like perhaps the only thing I really care about is the actual ID for the record or the ID for the presentation, because maybe there's two presentations with the same name. Like maybe at a conference, a presentation is being given twice or something like that. So it would have, of course, the same name, same presentation abstract, same speaker, but you would want to have still unique IDs between them. So like that, maybe instead of trying to compare all the fields within that record, really the only thing you maybe would care about is comparing the ID to confer equity. Again, also modeling data transparently also makes it very easy to aggregate the data. As you know, I add various records to another attendee to make a data aggregate. Any operation that is then working with that data aggregate will have full access to all the underlying fields and components of that data aggregate. So again, with like an attendee, so like we have like a person name record where it's like a first name and a last name. Then when I'm working with standard attendee and I want to get the full name, I can just drill down to the person name record. Another benefit of this is that you don't have, and also as kind of touched on here, you don't have to make your data super stringy. So instead of just using string to define the email address, perhaps you could use an email record and have that just to better signify and separate it when you're working with it just from a standard string, that it would have its own constraints when working with it. One moment. So it's also important to enforce immutability in depth. So records by default only provide shallow immutability. So you couldn't change the reference for an object, but if you were to use something like a list or an array within a record, it is possible to mutate that array or that list by adding or removing elements, which of course would kind of violate the assumed understanding of immutability of a record. So when working with such a potentially mutable object within a record, you would want to make sure that like the accessors are returning a unmodifiable copy of it, and then also when you're initializing that record, that you're also making a defensive copy of it that keeps it unmodifiable. And so yeah, so this would be an example of that this standard attendee, I have a list of favorited presentations, and then when I'm initializing it, I'm doing a copy of to create an unmodifiable list. And actually, technically, I can just pass back that unmodifiable list because it couldn't be copied either anyways. I don't really need to do that. I forgot to update that code example. Again, this is, I think, one of the best and most broadly applicable of some of these principles, that like even if you don't necessarily know how some of these things could apply to your systems. I think following this one of making illegal states unrepresentable, it's definitely, as I was going through data-oriented programs, like, yes, like this is very useful in almost all circumstances. But yeah, so when you're initializing a new instance of a class, or in this case a record, do the initialization of all the data at the time of initialization. If it's someone's always supposed to have a first name, then make sure it's not blank. And if there's any other sort of validation for what you would consider to be like a valid name, that maybe you would need to have at least some number of alpha characters in it. It can't just be a series of spaces or something. Whatever it is, make sure you do that validation up front, first name, with them, along with like any other fields, making sure like email is also valid as well. But yeah, I just know there's been many times in my career where I was stung by that, where somehow data, like I think, I have it being created at the boundary or something, and it's got set, and I thought by some point later in processing with it, like it should definitely be valid by now, but somehow someone was able to pass in a null email address, and then when I sent that off to the database, it caused the database to explode because that violated some rule, some requirement in there. Yeah, so making illegal states unrepresentable, improving that object construction, again, very useful. So then separating operations from data. Yeah, so modeling data, again, this only really works if you are having fully transparent data. So these external operations have full access to the state of the records or the state of any classes to then do manipulation to them. So for example, kind of what I was showing a little bit earlier with the object-oriented example, I wouldn't have the add favorited presentation directly within the definition of the record. Of course, that would obviously violate the immutability, but you also wouldn't just have an operation as well within the record. So instead, you would have some operation that would make a copy of the existing attendee and then update it with their new record. I will say, we'll get back to this here in a few minutes. This kind of gets to one of the current constraints of data-oriented programming within Java. That said, there is some flexibility around this rule. So for example, handling the printing of a name, maybe that would make sense to do that as part of the attendee class rather than having that be an external operation. Maybe that makes sense, maybe it doesn't, but it's just mostly to say that it's not like, as long as like that operation is not doing anything to manipulate states, it's a dominant right, operation, that might be fine to include that, especially if it's only going to be unique to that specific record or class. So when to consider using data-oriented programming? So it has like some distinct advantages and disadvantages. I think definitely probably its most key use case would be in some sort of an exchange, transform, and load, where you have one boundary where you do one set of transformations and then you load it into some other system. Also on some sort of a more small scale system, an actual microservice or a function. Of course, its disadvantages, of course, if mutability is important to you, then obviously data-oriented programming probably isn't going to work that well for you. And also maybe some sort of a larger scale system, a monolith, quote unquote, just because typically, again, within that, you're probably at some point, you're going to have long-lived objects that you're going to maybe be transforming over the life cycle of a request or a transaction, in which case that wouldn't really map well onto the principles of data-oriented programming. So yeah, usually this is a case where there's only going to be some sort of transformation, one single transformation of the data, or you're existing very much at the boundaries of data, as would often be the case like for microservices in ETL. So as I was going through this presentation and trying to put it together, like data-oriented programming, there's more niche use cases for it, whereas OOP is a very broadly applicable design paradigm. Like a well-designed OOP application can almost work in all kinds of use cases, whereas like there's, again, very specific kind of sometimes constraints around where you could use a data-oriented programming paradigm for designing the system. Also, that said, you don't necessarily have to think of like this is an OOP application and like you can't have any data-oriented programming anywhere within it. Like maybe there's a specific sub module of the system or something like that where you could follow data-oriented programming within that area if that makes sense for you. To kind of get into some of my personal opinion, maybe as could be picked up a little bit on here. Except as I went through this, like I wasn't fully convinced on data-oriented programming. I still really need opportunities to kind of work with it in practice. This is one of the constraints of being a developer advocate, unlike many of you who are actively working on supporting and running enterprise applications where you're getting new business requirements and having to meet the needs at set scale, where you can maybe really get some practices there. Anything I kind of work on is going to be a very arbitrary or small scale application that isn't going to be meeting that weirdness to really know perhaps some of the constraints of it. Also, sometimes I see like sometimes a lot of the value of data-oriented programming comes from the idea of just doing bad object-oriented programming, that if you're following really good principles of like solid and like actually like following through on solid principles, like switching to data-oriented programming, you may not necessarily see a whole lot of that. Also, it needs better definition, or at least needs some better definition within the Java world about good practices to follow, what constitutes data-oriented programming. But like I said, as I touched on a number of times, though, I think if there's anything to take away from this, though, is updating your code, updating your models to where illegal states are unrepresentable would be something that would be very useful to follow. Yes?
So I guess, what are the main concerns with using this for larger scale applications? Is it memory management?
No, not memory management. It would kind of come down to, yeah.
You just repeat the question.
Oh, okay. So and Cindy was asking, so what would be some of the potential downsides to using data-oriented programming in a larger scale application? And that is just because the models are supposed to be immutable. That means every time you want to make a change to it, then you have to do a whole copy of it, and then you would update it, which, I mean, I guess there is maybe some minor memory concerns about it. But one of the major issues, at least right now in Java, is if you have a very trivial record that maybe only has 2 fields, this doesn't seem to be much of an issue, but you have a record of any even trivial complexity, like here with this 4 fields, it's very painful to write this all out. I mean, just looking at this, it kind of makes your eyes bleed, that you have to first extract all the fields from one record, pass it to a second record, and then do whatever update to say like, okay, I'm only updating the list of favorited presentations, like passing that updated list. So if you're having to do that in a lot of locations in your code, that would be a very painful thing versus with object-oriented programming, where you can maybe make a update to that model directly.
But then by large-scale system, do you mean a system with a lot of code? Or
A lot of code. A lot of
you mean a system which is,
Yeah, no. So yeah, when I say large scale, yeah, sorry, I probably didn't use that correctly. I mean by like something kind of representing a monolith. I really probably just should have just kept it just straight to monolith. As far as performance, probably a well-designed data-oriented program might be more performant than a mutable one, just because usually when you have an immutable classes, the JIT can maybe do a lot more for optimization for it. So as far as like handling very high scale, there shouldn't be really any issues with the data-oriented programming. And again, might be actually a little bit more performant. It's just that if you're doing like a lot of mutation or needing to do changing a lot of states on your models, that's where a lot of the pain points of data-oriented programming. So,
but mutation doesn't necessarily mean having some kind of collection fields. Mutation might mean that I have an attendee, because the like for attendee, but I have some record and I really want to change it.
yeah.
Now I am creating a new record, which is fine because that's a new data, but that does kind of create pressure on memory management because now I have more objects, and it does create pressure on performance because now I'm kind of also deal with kind of additional object allocation and stuff like that.
Yeah, it shouldn't be too bad though, because it's not like you're recreating all the references. You're only really getting two new references, like the new reference for your new record, and then the new reference for whatever, or at least whatever then fields you're updating to it. It's just messy from a code perspective, at least right now. Is that like, okay, if I was updating the first name, I had the original first name, and then like I had a first name 2 that I'm switching it to or whatever, or updated first name, but I would still have to copy over all these fields. And so like I said, that's to me, I think the biggest drawback, and where data-oriented programming just wouldn't work well in a more monolithic application, just because a lot of times in a monolithic application, a lot of times you're going to be making changes to the state of objects within it. Yes.
What about fixed lists of objects?
Mm-hmm.
Data records.
Yeah.
Applying mutation to one. So when I delete one, do I have to copy the entire list of references?
Yeah. So.
The one that's not there, and then.
Yeah, if that's part of a record, yeah, that would be. Oh, sorry. Yeah. So actually, yeah. If I could take that, then I can pass it over to the. If you could repeat the question.
Yeah. So it's just about mutation of lists of records.
Yeah.
Right. So you have to copy the whole list over,
Uh-huh.
and then remove the one you don't want, and then it's compressing it literally.
Yeah.
By doing that. You'll still have the old list.
Yeah.
The old list references those original objects that are still in the new list.
Yes. Yeah, no, that's great. Yeah, like I said, it's just, yeah, if you're making manipulations, you would have to do a whole lot of copying over. It's generally not too much of an issue from straight performance or memory management, but it is just an issue from code perspective, readability of the code. Oh, okay. All right. Okay, thank you. Or did you have a follow-up, or did someone? Yeah. Okay. Perfect.
In case of relationships between objects, like for example, there might be an address object in here, or we may choose to model it as a reference, like in entity relationship.
Yeah.
So when the address changes, the main object is not mutating as such. The reference is mutating. So how does that?
Well, the reference wouldn't be mutating. You would have to create a new updated instance of that record and then copy it over, and then copy up any other records that was in referencing that address.
Okay, so are we, or if I'm getting this right, the entire graph of the objects needs to be cloned once we, okay.
Yeah.
All right. And a follow-up on this, if it has to be cloned, one of the aspects of, let's say, workflow, state diagram, as an object moves through different states, only some operations are permitted in a specific state because it makes sense.
Yeah.
If the application is new or review, so on and so forth. So the operations that are applicable in a particular state depends on the value of an variable.
Yeah.
So how can DOP help address these constraints, or can it?
So yeah, I think some of that. Thank you. That actually is an area where data-oriented programming can actually be somewhat useful. So like you could do like simulating multi-return values. In this case, I'm kind of doing it with, or yeah, you could have it to be based upon if something's in a successful state or like a new state, you could have it to be like, okay, then follow down this new path, or in this case, I'm using responses, but like interrupted, timeout, a failure. That is actually another area where data-oriented programming could be pretty good to be like, okay, this application's in a new state. You can model that out as different, you know, states for that model, and then you can have areas where you can have code pathing based upon the state of it. Yep.
Isn't this feature maintained by IDE?
Sorry?
Isn't this feature maintained by the IDE, the environment? I mean, just set the data mode and just impose this. I mean, but by the
like using this. No. So an IDE when it. I mean, maybe like IntelliJ or your IDEs, maybe they could help with code generation in that thing, perhaps. But it would still, I think, be a bit of no problem, a downfall again when it just a little bit comes to the readability of it. And at least, so I guess I do want to kind of get to like how maybe this could get a lot better in the future. So one of the JEPs that we have right now is called derived record creation, or a shorter name for it is what's called withers. And so instead of what I was showing before, where you would have to kind of almost manually copy over all the old fields to the new field of a record, what instead you could do is have like this width, and then whatever field to that record you want updated, you just define what that new state is, and then that will return you a copy of that existing record with the fields you are updated. So visually, this becomes a lot more comprehensible when this is eventually added. It's taking a bit of time because initially we were thinking of, by we, I mean the incredibly smart JDK engineers who are way better at this than I am. But initially when they were putting this together, they were really thinking about, okay, we're just going to be doing this for records, but we didn't want to, but then as they did more work on it, it's like, oh, we didn't want to only do this for records. How could we maybe extend some of these benefits to classes? And then there's also sometimes like a record comes with a lot of constraints, and then it's like, the second you need to violate one of those constraints for whatever reason, then you have to go all the way up to a class where, you know, there's a lot of overhead with that, like, you know, taking on all the pains of serialization. So one of the things they're working on is working on data carriers where there's a way of a more of a smooth transition between records and all of its constraints and a class, where you can maybe say, okay, maybe a few of these fields, you know, first name, last name, and middle name, we'll treat those as components. They're immutable. They have to have their accessors. They have to be set at the time of initialization and all that stuff. But maybe I could still have one other field in here that, you know, is maybe internal or something like that. So
because of today's finals.
Yeah, but there is more things. So like, even though I was to declare these final, it doesn't mean I would necessarily have to initialize it, or it wouldn't have to be part of the canonical constructor of the class. So if I was ever going to initialize this sorter record, then I would have to pass it, the constructor would have to include first name, last name, and middle name. So that would be one difference between final and component. And there would be a few other things as well that, you know, you would get an accessor to it. and so on. So yeah, we're trying to find a way where instead of making it a steep cliff between record and class, we can make it more of a smooth hill that you can kind of go up, where you can take some of those benefits of it. Of course, describing that goal is easier than actually achieving it. So they're working through a few different ideas of it. And again, this isn't final. This is just like an initial proposed idea to describe kind of like what they're going towards. It might eventually change a whole lot by the time it's actually implemented.
So having a record is one of the fields being a collection and modifying it is essentially what you're achieving with.
Potentially, yeah. I mean that could be one example. There could be many other areas where you might find a record too constraining, and so you would want to have this sort of record.
But you can do it with records today. It's not encouraged. That's what I'm saying. It's becoming encouraged.
Yes.
In other ways.
Yes, that is true. So yeah, so what I guess you were saying with you could do that with a record is that you don't follow good practices and you allow the record to be modifiable and stuff or not the record, but the list within a record to be modifiable. Yeah. So, but yeah, I think but again, to me, that's, I think, one of the big constraining points right now with data-oriented programming, as is within Java, is the lack of withers to allow for easy modification of a field and updating. Any other? Okay, 1 second. You want to pass that? Or thank you, Frank.
Yes, one question about records and pattern matching.
Yes.
So if we extract properties of records with pattern matching, what is the scope of visibility for these properties? For instance, we can extract with if closure. So we have an if block. And what if I would like to define the variable with same name as a property in this record? What's happened? Will compile fail, or it will replace the property? For instance, we have a record user with property name and age. Inside pattern matching, in if closure, I extract name and age. Inside this block, I define new variable with name.
Yeah.
What's going on? Will it fail, or it will replace, or because as I assume the scope is for this property will be inside this block.
Yes. So yeah, that's what. So when it comes to pattern matching, the variables that are defined within it, it's what's called flow scoping. And so what that means is that value will be in scope wherever the compiler definitely knows it to be true. So generally speaking, like if you were to find like an if instance of and pass a value out, it's going to be available within the following block. Like that's the proper way of doing it. But like strictly, you could do something completely dumb, be like if not, and then have like an exception here, and then in the else, like it would be available there as well, because but yeah, it would be available in that following block, because that's what's called flow scoping, but then it wouldn't be available outside of it.
Yeah. But if I define new variable inside this block, the same name as property, because there is no problem to get access to this property by instance of class. Object class, but property. But what happened in the case with pattern matching?
I'm not quite sure. Dang it, I don't know if I have it. Okay, perfect. Gene, yes.
All right. So flow scoping is sort of like a local variable. So a local variable can mask an instance variable, which means your flow scoped instance of variable can mask an instance variable.
Yeah.
You can't have a local variable mask another local variable, so you can't have like a lambda masking a local variable. You can't have a flow scoping masking a local variable or the like.
Okay.
It's like local variable.
Yes. Okay. All right. Yeah. Thank you, Gene. All right, any other questions? All right, I think I have a couple of more. Oh, I'm sorry. So yeah, but yeah, data carriers, hopefully when this stuff is eventually added, and again, data carrier isn't necessarily a finalized name, I think that will finally make data-oriented programming a much more practical option within the Java world. Like it's just at the base level of practicality, but this will make it a lot more practical. So on that, Brian Getz, he's a chief language architect. He wrote out his thoughts. He wrote this back out in January. And also, if you actually go to our YouTube channel, we have a video where, again, one of my colleagues, Nikolai Parlok, he did an interview with Brian Getz on the subjects of data carriers. So if you're very interested in that, you should check that out. Also, something that will have a relationship or impact on data-oriented programming is Project Valhalla, which is finally is on track to be integrated into mainline in JDK 28. It'll be as a preview feature. Really, it's going to be value classes. That's what's be integrated within it. But then there's also going to be some things like potentially like null restricted value class types that would also be kind of relational to data-oriented programming. Yes. Yeah, I think, sorry, man, but again, yeah, Brian Getz, he's the chief language architect for Java. So as a lot of these new design features, particularly on the language side of things, like he is having a heavy influence, or at least he is working with the implementers of it. So, I mean, there might be someone else like leading the idea of it, but like they're going to be at least into some degree dialogue with Brian Getz on it. So yeah, so follow-up links. This first one again is also from Brian Getz on data-oriented programming. So he kind of sketched out his own ideas. Let's see. Actually, I think I may need to update one. I think that's an incorrect link for this one. Again, this is the other link for by Nikolai, where he kind of updates on the ideas on data-oriented programming. I mean, I think this is even some of the areas where it's like, is it hyphenated or not hyphenated for data-oriented programming? I mean, I'm just saying, like, this is not me. This isn't my editorializing. This is actually the actual links from the article title. So that's how unsettled it is do you hyphenate it or not? Actually, I want to update this one, but it's still useful. Jose Palmared and I, we put together a, primarily him, but I did help. I did make my contributions as well. We put together a hands-on lab on refactoring an application from object-oriented programming to data-oriented programming. So if you go to this GitHub, this has all the instructions to it. And when I send this link to Frank, I'll make sure to update this to his most recent version of it, just so you get all the latest and greatest. But of course, it has instructions and all that stuff on how to go through that. So that can give you some more hands-on experience on the principles and stuff I talked about here. But yeah, any more questions then? Or yes? Oh, hold on. Yep.
So in general, the class of applications which revision data.
Yeah.
Right? So some state or some event occurs, the data has to be revisioned. Mm-hmm. So in this case, because everything is immutable, it kind of maps nicely to versioning.
Yeah.
So development of such applications where every version has a specific meaning what are your thoughts on how easy or in which areas it will benefit application development by following this paradigm?
So again, at least in my opinion, at least my thoughts would be that if you're going to be having multiple revisions to data over the lifetime of it, that probably isn't the best use case for it. But if you're doing like a single transformation of it, like, and that's what I was going back to for maybe some of the ones, yeah, would be like for something like an ETL application where you're modeling in one state and then transforming it into maybe another state. That would work very well for data-oriented programming. Or again, maybe for a small scale system like a microservice where you're taking in a request from a user, doing some light transformation to it, sending it to the database, maybe getting a response back and transforming it and sending that back to the user. That could also work. Like when you're at the data boundaries and you're maybe only doing like one or maybe two transformations of data, that can work well for data-oriented programming. It's if you're going to be manipulating data a whole lot, that's not going to work well. So earlier in my career, I worked for a company where we did insurance regulation, which is really riveting stuff. But one of the things one of the primary things I was supporting was applications that insurance agents would use to either apply for a new license or renew their license. And it was a whole wizard where they fill out a bunch of different forms and going through it. And then I'm progressively, building up this massive data aggregate, like, oh, here's a name, this is where they live, this is like that would not work well for data-oriented programming because they now have to be making constant copies of like a massive data object to like another updated instance and then adding a new field to it, or else it wouldn't work well because, I'm building up this object through different states because, if it's going through like 5 different pages and each page is adding stuff to it, then I can't fully define that object at the very start of it either. So like that wouldn't work well for it. So yeah.
So that was actually a great example. So it seems, and if my takeaways largely off, let me know.
Mm-hmm.
When an object transitions from one point to the other because of an event, it is more about capturing the rules at that point of transition. This is where DOP is very useful so that it's all immortalized in the code itself or the record itself.
Yes.
Okay.
Yeah.
All right. Thank you.
Oh, yes.
So can you clarify maybe what you mean by doesn't work well? Because that kind of, rolls back to my first question about kind of what, yes, it might be the code, but I think in your examples, it's not really about the code. What you're describing seems more like a pressure on performance and memory. So what does it mean it doesn't work well?
No. That is what I mean. It is very much just about the code that if you're using larger data aggregates, if your record has 12 fields and you want to update 1 or 2 of those fields, then you would have, when you create a new record, then you would have to pass in 12 of those fields again while updating 2 of them. And again, in this very simple example of this 4 fields, it does not look nice to have to go through this when you're updating a single field. Whereas in object-oriented programming, or if you have a mutable class, you would just do like a setter on that field and then update it or call it update method on that field to just update it directly instead of having to copy it over. It's not really too much of a performance issue because you're not, obviously when you're copying the references from one object to another, really nothing's happening within the heap. It's just, oh, okay, this other object has a reference to it. It's not really too much heap pressure, but visually maintaining it as a developer, reading it, it would be a painful experience, and then modifying it and updating it wouldn't be a pleasant experience, or maintaining the code, I should say, wouldn't be a pleasant experience over time.
Code readability and maintainability.
Exactly. So, I mean, if this doesn't bother you, that's fine. Like then go ham on it. Like I'm not saying don't. I'm just saying that would be one of the constraints if you were to try to use that in such as applications.
Well, yeah, in that space there are a lot of other things which in Java are too verbose and using.
Well, this
them.
is even taking
so,
another look. Yeah.
But I guess what you're trying to say is that the main issue today with records, I guess, is that they don't have enough call it syntactic sugar to make them kind of, you know, nicer looking.
Yeah, and again, that would be where withers and data carriers, when we eventually get, to that point, then it could become because you know this is imminently readable. That okay, yep, this is the only field I'm updating, and then we're returning a copy from that. That's very easy to read, and then at that point, it maybe become a bit of more style and preference. You know, like some people like. I've never been able to really understand reactive programming, but like some people love it. And
I do.
But maybe that's exactly my point. So, but like now we have like virtual threads where it gives you a lot of the benefits of reactive programming without having to follow those paradigm models. At which point, I'm just saying is to say is like, do I want to write this imperative style with virtual threads, or do I want to keep with reactive programming? And there could be some other additional benefits or arguments for that, but some of it could just be a style that like you really understand reactive programming, you prefer it, it makes it easier to read for you, in which case you might still stick with that. And that's what I'm saying is this, is that when some of these features get added, then you may be like, you know what, I just understand data-oriented programming, I just prefer it that way. And at that point, if you have some of these features, it will make it a more practical choice is one. Yeah, if you could pass over the microphone.
Yeah, I think the messy part is obviously there's a lack of language extensions or whatever to make this easier to code. But what you're gaining from that is that since it's immutable, it's all thread safe. So I'll gladly give you the thread safety headaches to deal with this part of it. Right? So you are trading one off for the other. And the other thing I like to point out is all the concerns about memory, right? When you recreate the object, you're creating the part that changed, and then you're reusing the references to create the new object. So you're only recreating the changed part, not everything else. You use the other immutable object, right?
Yeah, exactly. Yeah. So that's and that's one of the it could have been more clear earlier, but exactly right, that there really isn't a memory concern in that, generally speaking. So, so we probably have limited time here, so because we need to clean up. Any other questions or? Okay, well, thank you very much, and I guess glad to find your way out.